Now let's see this setup in action by stepping through the code. First, we'll need to set up the debug configuration, so let's start by coming up here to the Debug button. Then go to Debug As and select STM32C C++ application. Since this is our first debugging session, we'll need to configure our debugging environment. Starting with the main tab, just make sure that the project and build configurations match our current project setup. Then here, we should confirm that the debugger settings are as expected. Be sure that the ST-LINK is chosen as the debug probe, and that the interface is set to SWD, which is the recommended setting for STM32 devices, and that all other project options are correct for your setup. Once you've confirmed all settings, hit Apply, and then click OK to save the configuration and proceed with debugging. And as expected, and as mentioned in the previous lesson, we had set config generate runtime stats to 1 without setting up the required timer and counter function definitions. So we can go ahead and cancel this debug launch. So just cancel debugging the project. And here we can see that it says, if config generate runtime stats is defined, then port configure timer for runtime stats must also be defined, and that the port get runtime counter value must also be defined. We'll take care of this later in the course when we set up runtime stats for FreeRTOS. But for now, let's go to the FreeRTOS config.h file and make the quick adjustment. And down the file, here we have generate runtime stats, and let's just cut this definition so that we can make another section for it below. So let's just place that down here and make a comment, runtime stats configuration. All right, and I don't really like using the spell checker so much, so I'll just turn it off. Okay, that's better. Now let's just paste the definition here and comment it out. And we'll leave this as is for now and come back to it later in the course when we set up runtime stats. Okay, now let's go back to debug. And this time we won't need to choose debug as because we already have our debug configuration set up right here. So go ahead and select that to debug. And while this is in process, let's go back over to main.c. Okay, and this is just the Windows firewall. I'll just click Allow. And this is just asking us to switch to the debug perspective. Let's go ahead and do that. All right, so just give things a moment to settle. And here we are at the SystemCoreClockUpdate function, and now we're about to step into this function and understand how it sets up the SystemCoreClock variable. So let's use the Step Into feature of the debugger. And now we want to monitor our system clock's current value, and we have the SystemCoreClock variable just below, so we can simply drag this variable to the watch panel, or you can type its name directly into the expression field here. Let's go ahead and select the variable and drag it over. And we can see that this variable is already initialized to 16 MHz, as this variable is initialized towards the top of the file here. And the system_init function takes care of the default initialization, which means enabling the internal high-speed oscillator, or HSI, and setting it as the system clock source, which we're going to modify in the upcoming lessons. But for now, let's step through the clock update function to better understand the process. All right, so let's step over line by line using the Step Over debugger feature. Okay, here we're getting the system clock source. Let's step over, and then step again. And now the variable is updated with the default HSI value. Okay, let's step to the break. So in the next debugging step, we'll get the hclock prescaler value from the RCC configuration register, and when we step over, we're seeing a prescaler value of 0, which means there's no division of the system clock. As we can see now by stepping, that the core runs at the same frequency set by the internal oscillator at 16 MHz. But the main takeaway here is that we can use this function to keep the SystemCoreClock variable up to date. All right, so let's step over again and back to main. Now we'll go through the task creation process for the startup task. So let's step into the startup function here. Before we go any further, let's bring up the FreeRTOS Task List for monitoring task statuses. This will display our task list in the current perspective for easy monitoring. So go to the Window menu and select Show View, and then FreeRTOS Task List. Now we're going to step over the xTaskCreate function call, which initiates our startup task. Then we'll take a look at the task list to view its properties. Alright, so let's step over. Here we can see that our startup task was created based on the name that we've entered here. And the current state of this task is running. And the stack information provided here, start of the stack and top of the stack, helps us verify the task's stack allocation. And the priority level, displayed here, shows where this task fits within the task scheduling hierarchy. Next, we'll jump into the startup task and see how it deletes itself, and also how the idle task is started when we let the scheduler run. So let's now put a breakpoint at vTaskDelete, and we're going to let the program execute, and we'll observe how the task is deleted. So let's go ahead and hit the resume button. And here we are at vTaskDelete, and we can see that the idle task has been added to the task list, and you might recall that the idle task has the lowest priority and runs when no other tasks are ready to run. Okay, now let's visually confirm that the startup task is deleted by stepping over. So go ahead and step over. Then we can just hit Suspend. And now you can choose Do Not Show this message again if you like, so that you don't see this when opening large files. It's completely up to you. And as we can see, the startup task is no longer listed, which means it has been successfully deleted after completing its initialization duties. We're set to get into a more intricate system setup in the next lesson, starting with the clock configuration.